Hey guys, I fixed my issue with my writing, so now I get to write just as fast as I normally do. There's some button I had to press and I didn't know about it. So today we are talking about day 2 of transformation. So go ahead and label your notes. That. Alright, we're going to pick up where we left off. So I am going to give an example and we are going to graph together the transformation. So we've got y equals 1/2 of the absolute value of x minus 1 minus 4. Okay? First, we're going to do a little side note that the graph of the absolute value parent function looks like, well, that wasn't a very good one, but looks roughly like a V. And I'm going to try this one more time. And it goes through the points 1, 1, 0, 0, negative 1, 1, etc. Now, this graph here, there are 3 transformations that's basically happening. First, that 1/2 means that we are going to be compressing vertically by a scale factor of 1/2, which means we are going to take our y values and multiply by 1/2. Okay, so here is now going to be at 1, 1/2. And the same goes for this side. The second part of the transformations are the shifts. So we're going to go down 4 because it is on the outside of the argument. Anything on the inside that's messing with your your horizontal values, and anything on the outside is messing with your vertical values. So we're going to move down 4, and on the inside of the argument, I should do different colors. We are going to, let's do green. So for that one, we're going to go to the right 1. Notice it is minus 1, but we're moving to the right. So I'm going to show y'all how we're going to graph this. Let me move this up a little bit more. We've got our new function. Okay. We know that the x values are still going to be still be the same. We're just going to scrunch our y values with a scale factor of 1. So I'm going to do this as a dashed line. Okay. Now, our first points are at 1, 1/2. We got the 1/2 because we multiplied by a factor of 1/2 here. Notice the x values did not change yet. This is negative 1, 1/2. It's a 2. Teeny tiny. All right, so I'm going to do a dashed line. Now, we have to move our vertical and horizontally. So let's go down 4 into the right 1. So let's do blue now. And I'm going to extend my graph. And I'm going to have graph paper for y'all to use tomorrow. If you have some, you might want to bring some, but I have some as well. 3, 4. So we're shifting down 4. So we're going 1, 2, 3, 4 into the right 1. So my new point value, my new vertex is at 1, negative 4. And then it is at 2, negative 3.5 for my next point. And the same is true. I'm moving to the right 1, down 4 for this one. And I'm at, whoa, that's a little far off. I'm at 0, 1/2, and there it goes. So this point is at 0, negative 3.5. So that's basically how you do your transformations, and that's how we graphed the y equals 1/2 of absolute value of x minus 1 minus 4. Okay, you'll have practice problems like that in class tomorrow. The next thing I'm going to talk about, because there's two questions on that, two more questions, so let me get a new page. And this is going to bring in some Algebra 2 skills, so you got to sharpen up those skills a little bit. It's changing the form to transform a quadratic equation. Okay, so let's show you. So if I asked you to graph y equals 2x squared plus 12x plus 19, okay? First thing, it's called completing the square, and I'm sure y'all have heard that before. We're going to ignore the 19 for right now, so we're just going to put that on the end. So we're going to put plus 19 on the end. Now, the first two terms, I can pull out a 2, so because they're both divisible by 2. When I do that, I now have x squared plus 6x. Okay? Now, we need to get a last term in here to complete the square. The way you do that is you half the middle term, so you divide it by 2, and then you square it. So 6 divided by 2 squared is 9. Now, if you add a 9 here, you're going to have to subtract that number on here, on the outside, because it's got to equal to 0. It would make it unbalanced if you didn't do that. Now, we're not just going to subtract by 9. We actually have to subtract by 18 because we need to multiply it by the number here. So I'm going to do a different color. So I'm going to subtract by 18. Okay? Next step. We are going to factor. You will be good at factoring. If you're still a little rusty on it, I suggest you Googling the Khan Academy and looking for factoring videos. There's thousands of how-to factoring videos out there, and that's a skill you should have learned and should have had down by Algebra 2. So we've got to factor this middle term, and the reason we do the completing as a square is because x plus 3 all squared equal x squared plus 6x plus 9. Okay, so that went here. And then we're just going to add and subtract here. So 19 plus 18 is just good old plus 1. Now, we're going to take it one step further. We're going to describe what just happened. Okay, so if I asked you to graph this, and I want to keep these notes short, and I'm not going to, but if I wanted to know how to graph this, you would have to tell me that we're going to stretch vertically because 2 is on the outside of the argument. It's not inside the parentheses, so it's on the outside of the argument. So we're going to stretch vertically by a factor of 2. So that means we're going to take our y values from our quadratic parent function and multiply by 2. Then we are going to go up 1 So shift 1 unit up. And then last but not least, we are going to move to the left. Okay, notice it's plus 3. So most people think we're moved to the right 3, but we actually go to the left 3 because it's on the inside of the argument. So if I asked you to graph, that's what I'm looking. I would have you graph that, but I want you in the habit of this is how we translate functions. Okay? And be ready for a quick little short quiz tomorrow over the notes that we've done so far in class. It'll be your first quiz, and I'm also doing a notebook check. So keep that in the back of your mind, and good luck, and I will see you all tomorrow.